Okay, hello students and welcome to the lesson. Today we're going to start on arithmetic sequences, and today we want to be able to use recursion to generate an arithmetic sequence, display the terms of an arithmetic sequence in both tabular and graphical form, and demonstrate that arithmetic sequences can be used to model linear growth and decay in discrete situations. Now we'll do that more in next lesson, but just keep that in mind. And we're going to really hammer this rule today. So the rule for the nth term, using the term that the term number equals the first term plus that number minus 1 multiplied by d. Now where t sub n represents the nth term of the sequence, whereas t1 equals the first term, n equals the term number, d equals the common difference of a particular arithmetic sequence from the pattern of the terms in an arithmetic sequence. And we're going to use this rule to make predictions. Now I will just make a note that your textbook will also call T1 an A as well. So if you're looking at your text, you'll see that pop up. So let's have a look at the following sequence. We've got numbers 3, 5, 7, 9. So we can just say, well, the first term here is, this one here is term 1, but you can see first term is 3, then the next term is 5, then 7, then 9. So we can say the next term in the sequence is equal to the current term plus 2. So if we consider this, the next term here, let's get a different colour pen, the next term equals the current term plus 2. We also come across this arithmetic sequence formula from our formula book, so you'll get this one in your exam situation. And what can you see? You can see that the term number equals first term plus that number minus 1 multiplied by d, which is a common difference. Now if we have a look at d, the common difference, now to work out if something is an arithmetic sequence, it's going to have a common difference. So a difference is what? Minus. So if I'm going to look here, if I'm going to look at the difference between these two, what 5 take 3 is 2, 7 take 5 is 2, and 9 take 7 is 2. So you can see that the difference, remember difference just is minus, and it's common, so it's 2. So yes, this is an arithmetic sequence. Now we can also just call 3 the first term, 5 the second term, 7 the third term, and 9 the fourth term. So when that's just saying when n equals 1, that's the first, second, third, and fourth term. Now, as I noticed at the start, that the T1, your textbook will also call it A. Now, we can sometimes, if we're working with time, we can just say the first term equals 0 sometimes as well. So we're getting this idea of a recurrence relation, and a recurrence relation is just defined by the previous term. Now the process for determining these successive terms is called recursion. Now the syllabus glossary explanation describes an arithmetic sequence as a sequence of numbers such as the difference between any two successive members of the sequence is constant. So it's just a constant or a common difference. So let's have a look at two arithmetic sequences. And first of all, we just want to generate, what means bring into existence, the first 4 terms of the following arithmetic sequences. So we've got t, n plus 1 plus 5, with the first term starting at 9. So we said that the first term is 9. So to work out the second term, we're just going to say, well, that's the first term plus 5. So that's where we get that plus 5. And we started off with the first term being 9. So we're just saying 9 plus 5 is 14. So T1 is 9, T2 is 14. Now, the third term is just going to be term 2 plus 5. And so the term 2 was 14, so 14 plus 5 is 19. So that's term 3. And term 4? Well, that's just going to be that 19 plus another 5, so that's going to be 24. As you can see, that's a common number that we're increasing by. Now, an arithmetic sequence can also be negative. So if we have a look at this one, we've got the successive term number, so tn plus 1 with the first term being 5. So the first term is 5. We want to generate the next 3. So we said, well, the first term is 5. So we're saying 5 minus 3 equals 2. So T1 equals 5, T2 must equal 2. Now the second term was 2, and 2 minus 3, well, that's got to be negative 1, so that's term 3. And then for the term 4, it's just that negative 1 minus 3, so that's term 4. Now we'll have a look at this in a little bit more detail next lesson, but you can note that for these two arithmetic sequences, we can display them graphically. So we've just got term 1, term 2, term 3 and term 4. I've displayed them as a linear graph, and you can see that the difference is constant as they go up or down. So remember, we're going up by 5 each time, so we're going from 9 to 14. So that's up by 5, and then from 14 to 19, so that's up by 5, and then 19 to 24, that's up by 5. Now we can also have a look at the next one, minus 3. So our first term is 5, and we're going down this time. We're going down negative 3. So the what did we say that was? That was negative 2. Oh, that was just 2. Yeah, 5 take 3 is 2. Then we're going down another 3, and then down another 3. So you can see that that's a constant difference. Now let's verify that a sequence is arithmetic. And so we just need to ensure that that common difference is constant. So that means what? The fourth term take the third term is the same as the third term take the second term, and the second term take the first term is going to be the same. So let's check whether the following sequence is arithmetic and find the value of the 25th term. So here we have our first 4 terms, so 15, 37, 52 and 67. Now if I were to minus them, so 67 take 52 is 22, 52 take 37 is 22, and 37 take 15 is 22. So the common difference is constant, therefore we have an arithmetic sequence. Now we need to use that formula to generate the 25th term. So that's this one here. So what we need to do is just substitute into the formula. So we know the first term. Here's our first term. And then we're saying, well, what is going to be the 25th term? Yeah, so it's going to be the 25th term take 1, so 24th term, and we're going to multiply it by 22 because 22 was our common difference. So to find the 25th term, we just get the first term and multiply it by, get that first term and add it to 24 times 22. So that's 543. So we just say the 25th term of the sequence is 543. Now if we want to determine the rule for an arithmetic sequence, so remember that's just substituting into that. So we need to find the first term, so that's T1, or your textbook will use A, and the common difference, and use the formula to solve for Tn. So determine the rule for the following sequence for the 50th term. So we're finding T50. So here's our sequence. We've got 14, negative 3, negative 20, negative 37. So the first term, T1, is 14. Now that common difference is negative 17. Now I did that just by inspection. That means by looking at it. I haven't verified it as I have done in the previous one, but that's okay to do for the moment. So we find our formula. Here's our formula, and I've just rewritten it here and substituted in what I know. So I know my first term is 14. So I've put that in, and then I know the common difference. So the common difference, what was? It was negative 17. So that goes there for D. Now I want to find the 50th term. So T50 equals what? Our first term. And then it's 50 minus 1. So it's 49. So there's our 49. And we're going to multiply that by our common difference, which is negative 17. So that will be negative 818. So our answer is the 50th term of the sequence is negative 818. Let's identify the position of a term in a sequence. So what we're going to do is we're going to find the first term and then the common difference and substitute the value of the term number to solve for n. So for the sequence 12, 17, 22, find the position of term 222. So what do we know? We know the first term is our first term. We know our common difference. 22 take 17 is 5, 17 take 12 is 5. So I just did that by inspection. And then what do I want to find? I know my term number as well. That's 222. So we're just going to substitute this into the formula, which I rewrote here. And then let's go. See, 222 equals the first term, which is 12, plus the unknown multiplied by 5. Unknown minus 1 multiplied by 5, sorry. Now I'm just going to rearrange that with inverse operations. So remember the inverse, so we're transposing the equation. I'm moving that plus 12 to the other side of the equation, so it becomes, sorry, the other side of the equation or equal sign. So that becomes negative 12. Now remember, if you don't see a space between the brackets and the number, it's a multiplied, so I've just made that obvious. And so let's run this through. 222 take 12 is 210. Now the opposite of times 5 is divided by 5, so that's what I've done down here. 210 divided by 5 is probably 42, plus 1 makes it 43. So 222 is the 43rd term of the sequence. Okay, the next one is to generate an arithmetic sequence given two terms. And this is where we use simultaneous equations to solve for the first term and the common difference. So we want to generate the first four terms of the sequence. So it's one sequence, but we know the 7th term and we know the 20th term. The 7th term is 101 and the 20th term is 270. So this is what we know so far. So we're going to rewrite these two terms into the equation. Now I have made the first term the subject of the equation. So you can see that I have rearranged or transposed that equation to make T1 the subject. Now your book will also call that A. So we know that the first term, the 7th term is 101, and it's just going to be, well, n take 1 is what? 7 take 1 is 6. So that's where I've got that 6 there. And so we're just saying, well, the first term is the same as saying 101 take 6D. Now I can also use the 20th term. And you can see that 270 equals that first term multiplied by, plus 19 times D. Now I got that 19 by saying n minus 1, remember. So the 20th term minus 1 is 19. So that's how I've got that 19. Now you can see that I know what T1 equals. I've been given that there. So instead of writing T1, I'm going to put in this here. And I'm just going to rewrite that. Now I've done that in pretty colours just to help it stand out. So you can see that I've just combined those two equations. Because I've done that, you can see that I can solve for D now and find the common difference because it's just that one sequence. So move 101 to the other side of the equal sign and I'll collect the like terms and solve. And so 270, take 101 is 169. 169 divided by 13 is 13. So D equals 13. Now I know what D equals. I can go back to my first formula and substitute in 13 for where I see D. So I'm just saying, well, it's 101 minus 6 times 13. So that will give me 23. Now I can just substitute that into the arithmetic sequence formula and find the next 3 terms. So I know the first term, and then I can just go and collect the next 3 terms. So the first term is 23. I know that the common difference is 13. So it's just 23 plus 13 is 36 for the second term. 23 and 26, 49 for the third term, and that should be the fourth term, should be 62. So my answers are, the first 4 numbers of the sequence are 23, 36, 49 and 62. We've done a little bit back for our first real lesson of the year. Are you able to use recursion to generate an arithmetic sequence, display them both in a tabular and graphical form, and demonstrate that they can be used to model linear growth? And we'll look at that in more detail next lesson, I reckon, but this is the one I'm particularly interested in today. Use that rule for determining particularly what D, once we find D, and once we find the first term, we can solve the rest of the problem pretty well, and we can use that to make predictions. Once you've done that, I've put some mastery exercises there for you to work on, please.